My name is Suresh Andani. I run the enterprise AI business at AMD. Joining me today are my two esteemed partners here, Amin Badawi from Rackspace, a very close partner. We recently announced a big partnership deploying about 16 megawatts of capacity over the next few quarters. So very happy to have Amin with us. And then Saurabh Saxena here. He's from Uniphore, another one of our very esteemed partners, providing an enterprise AI stack that really brings the performance and the reliability out of our GPUs. So thank you so much again. And I'm going to go cover some of the aspects of our latest announcements with 350P card today. And then Amin and Saurabh are going to come and talk about how they are helping us take it to market and get the full stack solution ready. Right, let's see if this works. Okay. All right, so let me build this up a little bit. All right, so you're hearing the words tokenomics, token tsunami, token maxing, all of those. Literally in every enterprise conversation I go, this is the first topic that's being discussed. I just came out of an executive roundtable, which we had about 15 to 20 enterprise customers. We're supposed to cover like 5 different topics in the 45 minutes, but 40 minutes we're just talking about this exact thing, right? So all of this is real. The token costs are coming down. Cost per token is coming down, but the token usage as the enterprises are going from pilot to production are going exponentially up. So what's that causing is about anywhere between $500 to $2,000 token budget per employee. Think about that for a second. If you're providing about $2,000 of token budget per employee and you have 20,000 engineers in your enterprise like AMD does, that scales to about $400 million a year of token costs. It's not just, if you could predict that it will be $400 million of token cost up front in the year, you can kind of budget for it. It's hard, but you can still kind of budget for it. But what's really happening is with these multi-agent systems, multi-turn agents, and if your context is not grounded into your enterprise data, that creates lots of wasteful tokens, and that cost just becomes unpredictable. So it's not just high token costs is the problem, but token cost predictability and budgeting for that is becoming even a bigger problem. So Uber came out publicly a couple of months ago in April, and that said, hey, we had the full year budget for coding agents with Claude, and within the first 4 months of the year, within 5,000 engineers, that budget is kind of completely consumed. So how do you plan? How do you plan a business around if you cannot predict the cost? That's a big problem. And Microsoft came up with something very similar. I won't go through each of these cases, but you get the point. So today's agents, the easiest thing for the enterprise, like everybody is getting into agentic AI. The business processes are becoming agentic. The coding is becoming agentic. And today's agents, the easiest thing is to like, hey, I'll go run a agent runtime on my PC, but now I'm going to go point everything to the cloud API. And that's the easy button to really get your AI use cases, like because it's super easy to point a URL to an API, and then you can just go and implement your agents there. So today's agents, almost 80 to 85, maybe 90% of the enterprises are using cloud APIs today, the frontier models, to really serve the inference layer of their agentic stack. There is no self-learning. You don't have much control, right? You really are at the mercy of whatever is put in the cloud out there. Exponential token costs we talk about, and there's energy and cost burden that comes with it. But as we go into like, hey, for the first 2 years, you're running pilots, token cost was not a big issue. You're running the agents with the inference running in the cloud with the large LLMs, the frontier class LLMs. But as tokenomics is becoming not just a CFO or a CXO level discussion, but a board level discussion now. The future of the agents are going to be a little bit different, right? So there will still be frontier models that you will go to for use cases that really require, that are bursty, that will require high concurrency, that require like 1 million plus token context length. So you'll still go to your frontier APIs, but there is a lot of enterprise business processes, a lot of other AI use cases that can run very efficiently through fine-tuned SLMs. And Saurabh is going to talk a little bit about that in a bit. We have, again, the whole thing started with like cost effectiveness. So the future of agentic will be fine-tuned SLMs, domain-specific. It's driving higher accuracy because it will be grounded in your context. Latency becomes a big issue for real-time AI workloads. So for all those reasons, there will be use cases or there will be scenarios where you got to run open source, open weights, fine-tuned SLMs, grounded in context to your data on-prem for lower latency, higher performance, and better token costs. We can't do this alone. AMD produces the best compute engines, whether it's CPUs, GPUs, embedded, AI PCs. We need, obviously, we cannot throw a bunch of hardware at enterprises and expect them to get the value and be able to develop the agents. So there's a partnership we are forming. Today we're going to talk about the partnership between AMD, Rackspace, and Uniphore. So what we announced today in the keynote, if you attended that or caught up on that, is our latest MI350P PCIe GPU card. What that does is a lot of enterprise, about 85% of the enterprise racks today are under 30 kilowatts. Some of the bigger enterprises, larger enterprises, Fortune 50 or so, who are doing like capital markets, high frequency trading, drug discovery, they obviously have retrofitted their data centers to run liquid cooled, to run 60 to 100 kilowatt racks and even higher. But a majority, again, about 80% of enterprise data centers are still air cooled, and they are like less than 30 kilowatts rack density that they can support. In order for us to bring AI to data in a form factor in the data center that already exists, that they're already used to with the servers they already buy, what we needed to bring out is our PCIe GPU card, 350P. We are very excited about that. It is getting into production status this week. We launched this week. And then on top of it, we got to make sure that they're easy to operate. You're not getting into the ROCm kernel levels. You're not getting into the library levels. Majority of the mainstream enterprises are going to run agents that pretty much needs to point to a model, whether it's open weights model or fine-tuned model. So to get all of that stack working, we needed to provide as AMD needed to provide that reference stack, which enables you to really go operate those GPUs, run the models without having to go to the lower level details. So we're going to talk a little bit about the enterprise AI stack. What we're also doing is using that layers of those stack and integrating that into the Rackspace, the Rack AI, and Amin is going to talk a little bit about that in a bit. So we're also putting 350Ps. Rackspace will have it across multiple regions, 3 regions to begin with, and then we're going to go expand from there. So getting our GPU cards into Rackspace servers, into regions worldwide, that's step number 1. Optimizing and building on our enterprise AI stack layer, the Rack AI optimizations that Amin is going to talk to. And then Rackspace has a huge track record and years of experience supporting enterprise customers on their traditional workloads, now moving on to AI workloads. So that kind of adds to that equation. And then on top of that, Uniphore has built an amazing stack, which starts from like optimizations. It does autonomous fine-tuning. It has the data layer at the bottom that really has connectivity to all of your data sources. So it's all autonomous. You don't have to really go and pretty much manually tag all the semantics. So it's a lot of innovation in there that Saurabh is going to talk about. And then really taking the open weight LLMs and using the Uniphore stack and doing domain-specific SLMs is key to how we reduce the token costs and improve sovereignty. So we're going to talk a little bit about that. But when you kind of add these three, compute provider like us, an infrastructure provider like Rackspace, and a full software provider like Uniphore, the combination of 1 + 1 + 1 is greater than 3 here, brings the entire solution to the enterprises, what I call infrastructure to intelligence. So that's key here. All right. So I'm going to talk a little bit about AMD strategy. So we have 3 pillars. We want to go bring the best compute platforms. Look, AI is not just data center. AI will be starting from AI PCs for developers, for local AI enablement, going into certain AI workloads. Your CPUs are going to be just good enough and very much cost-effective compared to the large-scale GPUs. But then beyond that, if you scale up from there, you're going to go into your edge use cases where you really can't put 60, 100 kilowatt racks. So we go and put our PCI Express, like PCI GPU cards, both Radeon and Instinct, state of the art over there. And beyond that, if you really want to run a coding agent on-prem, that's where our 8-way GPUs come in, which is the third picture over here. And then ultimately, when you go into neoclouds or hyperscalers, we also launched our Helios solution today. So really going from AI PCs to local, to edge, to data center, to cloud, it's a continuum of AI compute that we want to bring in, which is best in class compared to anybody else in the industry. Beyond that, there is a software layer. There is a full AI stack. We need to be able to, we don't want our enterprise to say, hey, if I really want to run the latest DeepSeek model, R1 model, or if I want to run the latest Kimi 3.0, which is the rage this week, where do I go find this? Or do I have to go to some GitHub? Where do I find the drivers? None of the enterprises want to get into that level of complexity. None of you guys want to get that. So what we want to do is to really abstract all of that complexity, and that's exactly what our enterprise AI reference stack does. Again, layers of the stack, we are kind of integrating into our partner enterprise AI stacks like Uniphore's, especially our AMD inference microservices, which are containerized, optimized models, hardware aware, has the best drivers. So the strategy over here is to make it easy to use, easy to deploy. So that's a middle layer. And again, we got to go to market with our partners like Rackspace and Uniphore. So our third pillar of the strategy is to really go do this as a partnership. All right. So cover the first pillar a little bit. In the data center space, we have 3 solutions. If you are running like hundreds of users, like not thousands or tens of thousands of users, the model size is up to 20 billion parameters. More so, and if your deployment environment is between 10 to 20 kilowatt racks, so think edge. If you are under all these constraints and you're trying to do like edge AI, retail use cases, VLMs, diffusion transformers, image generation, those kind of use cases, that's our first Radeon AI card. Today we're going to talk a little bit more about the MI350P because that's the news of the day. Now when you go beyond those use cases, now when you go into your data center, when you're running your rack pipelines, when you're running your business process agents, such as finance, HR, trade, where you're serving like maybe thousands of concurrent users at the same time, this is where our MI350P card, which is based on HBM3E, comes into play, which exactly can do those at very compelling economics. But now think about beyond that. Oh, I've been using Claude Code to run my coding agents. Now, because I'm HIPAA regulated, I'm GDPR regulated, or if my token costs have gone beyond what I can sustain, I want to do part of the code generation or review on-prem. And now I want to serve tens of thousands of concurrent developers a PCI card will not be able to kind of support that kind of bandwidth and concurrency that you need. This is where our 8-way MI355X comes in, which is available both in air-cooled and liquid-cooled. All right, so maybe a little bit double-click into our MI350P. I call it, that's the easiest way to get AI to your data. So far, again, 90% of the enterprises are taking their data to AI through frontier models in the cloud. But a lot of enterprises, because of governance, security, control, token cost, cannot do this. They want to bring AI to data. But the problem is that data centers cannot do liquid cooling. It will take 2 years for them to retrofit it. The data centers cannot support 100 kilowatt rack power densities. So this is the easiest way. With your existing servers, you can put in an HBM3E-based GPU card, which can serve models up to 260 billion parameters. So think about not just GPT OSS, but models that go way beyond that with enough KV cache context left to serve multiple users at the same time. It is air-cooled, as I said, between 450 to 600 watt TDP, so you can simply plug in into one of your existing servers. But really what it boils down to is economics of it. We've done a lot of benchmarking against RTX Pro 6000, which is our competition, NVIDIA's PCIe GPU card, and we are able to see 4.2x token per second per dollar. So not just productivity, but productivity per dollar, intelligence delivered per dollar, 4.2x versus RTX Pro 6000. That comes in because the amount of compute we are able to pack in this form factor, that comes in because we have a 144 gigabyte HBM3E memory versus GDDR based memory, so huge bandwidth advantage compared to RTX Pro. Your decode-centric AI workloads run very fast on a MI350P. So really excited. We're seeing a lot of great traction from customers on this. So benchmarking, like based on some benchmarks is easy, right? So what we wanted to do again is test this against the competition for real enterprise workloads. So we kind of benchmarked 3 models, Llama 3.3 Instruct, and we did workflow automation use case with that through our IT. We ran a Mistral small 24 billion parameter models and ran a customer support use case on that. And then contract analysis, which was more of document analysis, more text model, which was using GPT OSS 120B. So we are seeing anywhere from 2x tokens per second to 5.1x versus RTX Pro 6000. This is huge uplift in terms of performance, in terms of throughput delivered versus the competition. Again, these were measured at about 1K ISL, OSL, and concurrency of 256 users at the same time. All right, so these were still all theoretical because what we did was we measured some models and we looked at tokens per second and compared it, right? But again, I want to kind of show a comparison about, think about an enterprise who was running all of their agents, like autonomous threat detection, which is a security agent, their code gen agent, personal agents. They were all running 100% through frontier APIs going to Claude or a GPT 5.5 or now 5.6 Sol. Compared to that, we said, hey, let's build an intelligent token router, open source. VLLM semantic router was used in this case. And write some policies around, hey, my code generation is going to serve 20,000 developers at the same time, needs, again, large context length, high concurrency. Let me write a policy to put that on the frontier. But then autonomous threat detection, 24/7 security analysis, that was kind of steered to local models. Like we ran it on on-prem 350P, Qwen 72B parameter models, and then we ran some of the OpenClaw agents that were pointing towards MI350P Gemma 31B. So when we did that, we were able to, and then this was the real pilot that was run within AMD IT. When we did that, we were able to steer 56% of the tokens to MI350P on-prem, with the remaining 43% escaping to cloud APIs because of the use case, because of the requirements that the workload had. And when you combine the two, what we're able to see is 43% cost savings versus running 100% frontier. So think about this. If we have a $400 million token costs, and I just got off again from the roundtable, I said one of the big enterprise customers in the FSI said their token costs are running about $1 billion per year. 43% of that is $430 million. If you're able to kind of intelligently steer your tokens and put part of that on-prem locally on an MI350P and a CapEx model, you don't have to worry about rate limiting. You don't have to worry about token maxing. You're able to kind of save 43% of your costs. Not just costs, latency is super important. We also observed that for latency-sensitive workloads, especially security threat detection is very latency sensitive. We're able to get 2.9x faster response time serving locally on an MI350P versus going to the frontier models through the cloud APIs. Okay, so all of that is great, but how do we go bring this stack together? So our enterprise AI reference stack, which is something which we provide open source. We don't charge for it. You can find it on GitHub. It's supported through AMD support. Like if you put that together, it gives you all the layers, all the way from data layer to inference layer, to observability, to governance. And then we have all of these upstream through open source frameworks like VLLM, SGLang, all of those things. One key layer in this stack is containerized AIMS models, AMD Inference Microservices. So we are taking all of the day zero optimizations for the latest models, translating them into containers that basically are Kubernetes containers that basically have all the latest drivers, all the best known configurations, settings, VLLM engine in the backend, in some cases SGLang engine in the backend, all containerized that you can find from GitHub from us and just point your agentic workload towards these. You can start on day zero once you get your gear to start running these agentic AI workloads. So this software layer enables to do that. And I kind of covered a lot of this. I talked about AMD Inference Microservices. We're also building some blueprints for FSI. We are building some blueprints for telco. We are building some blueprints which are basically reference architectures for specific industry use cases. These are, again, open source that you can go and implement it yourselves, like from GitHub. And then AMD AI Workbench is all your fine-tuning, observability, all those things in there. And AMD Resource Manager is what helps you, Kubernetes layer, to control your fleet. Some of our partners take some of these layers and integrate into their own stacks. Other partners take more of these layers. So really, this is meant for enterprises to take it as a reference stack. Some of them might use it for production workloads, but a lot of our enterprise AI partners who are building the stacks are leveraging some layers to go integrate into their own enterprise AI stack. So one of them, I'm going to go invite Amin now to stage to talk about how Rackspace is leveraging this for their stack. Thank you, Amin.
Thank you, Suresh. Thank you. Hello, everyone. My name is Amin Badawi. I run our enterprise AI platforms for Rackspace. I would like to start with tackling this from a slightly different angle based on the conversation that we have with customers that are interested in consuming AI and integrating into their ecosystem. One of the major challenges that we find our customers talking about, obviously infrastructure is important, GPUs are important, they're core, but it's questions like, who's going to run this platform? Is my data safe? Is my data secure? How to operate this 24/7? And I think this is where Rackspace actually fits in this model. We've got 25 years, as Suresh said, supporting critical workload across all verticals, or most verticals, in private cloud, in public cloud, and also on the edge. So that's our right to play in this ecosystem. The second piece that we have noticed is that AI is not going to live in one place. We're going to see it in manufacturing, we're going to see it in sovereign data centers, we're going to see it on the edge. So what Rackspace is offering from an operational perspective is one single platform, regardless of where it is. Same service model, same framework to support it, same outcomes. So how are we doing this? Okay. So as Suresh kindly said, we have partnered with AMD. Very happy about that. The reason we're doing that is because we believe on the value that the MI350P brings into the table. And that goes into all the figures that Suresh has mentioned and stuff like that. We're starting by deploying this in our US data centers, but we are going to very quickly move into our global footprints. And that includes EMEA, US, and APAC. The vision is very simple, is to provide customers with MI350P as a starting point clusters that are performant, optimized, using all the technologies that AMD brings to the table. And we've been working with Uniphore as well to learn from their optimization techniques and integrating it into our inferencing and fine-tuning service that we call Rack AI. That allows us to provide our customers with an end-to-end platform that is 24-hour supported with the expertise that we've gained for the last 25 years on supporting these kind of workloads. Because at the end of the day, AI is just another workload that adds to the workload that we support now. What really makes this solution complete is what Uniphore brings to the table. It's an enterprise AI business suite, that's how I look at it, that provides a front that allows you to do agent creation, ingest all the data within your enterprise, all that using techniques that are quite new to the market, but have major impacts on the cost. Taking back to what Suresh was mentioning earlier. So, I'm not going to bore you with the details. These are what's going to be the 4 pillars that constitute the portfolio that our customers are going to consume. I don't think of them as separate products. I think of them as different entry points to the same offerings with different capabilities. Because all customers that are consuming AI are at a different level in their journey, and AI is not really a single project, it's a journey. So customers that are interested in control, sovereignty, can consume bare metal. Customers that are comfortable with Kubernetes, which is the industry standard, can consume that. Some customers, and most customers that we're talking to these days, don't even want to get involved in the hardware side of things, so they can consume our inferencing as a service. So altogether, like I said, it's not 4 separate solutions or products. It's one with different capabilities, all managed, supported 24/7 by experts. Lastly, I'm not going to, this is the bit that touches on some of the stuff that Suresh has mentioned, but very high level. We've worked with AMD on optimizing the hardware stack, whether it's the kernel, whether it's the GPUs itself. Really, the goal there was to maximize the use. Going upwards, Rack AI, think of it as the business logic there or the brain there. We worked on batching, we worked on different techniques, like speculative decoding and stuff like that. I'm not going to touch on the refrag, because Saurabh is going to touch on that. He's the expert there. But really, the outcome there is faster throughput, faster time to the first token, cheaper inferencing. That's really what the solution itself, if you put it all together, with Uniphore at the top providing the business outcomes, that really what the customer is interested in. The rest of it is just hardware, but really what's the solution is the business outcome. So with that said, I'll pass it on to Mr. Saurabh.
You sure it's not you? Right. For whoever is awake anyway, my name is Saurabh. I am going to represent the company called Uniphore. We are a business AI enterprise stack company. And for this session, we wanted to cover essentially the whole thing in two parts. One, that Suresh mentioned, autonomous fine-tuned small language models. A fine-tuned small language model that learns from your own data, your own context. We have hundreds of precedents on this now that it will perform better than a large language model, more accurate, better context recall, better completeness, better faithfulness. All metrics will live up. And it will cost a fraction. And that's why I say, we don't have to pay for somebody's fourth rocket ship or somebody to buy Pluto now. We have to do it in a way that we are funding our own enterprises, not somebody else. So the value of a small language model, and then additional optimizations on inferencing that you still want to attempt. Because just reducing the token size or reducing the footprint of your model is not enough. You have to continue looking into inferencing and say what additional optimizations I can provide. So those are the two main topics I'll cover. Uniphore by itself, we are a VC-funded company. AMD was kind enough also to be an investor and a partner. We have a business AI cloud stack, and we serve Fortune 100, Fortune 1000 customers. So I thought it might be kind of fun to take a look at one specific problem to understand how a small language model actually helps. So we are working with one of the largest energy companies. And the problem was 60 to 65,000 vendor contracts, each one of them between 200 to 1,000 pages long. Service orders, change orders, amendments, the whole 9 yards. 2 to 2.5 million invoices, handwritten text on printed paper, all sorts of annotations and signatures and part numbers and part prices and quantities mentioned, handwritten. If this system were to run against, say, Gemini or an OpenAI, we were looking at close to 50 to 70 billion tokens a day for just processing this. And that is a humongous cost. Also remember that in contract type of systems, output context size is large. It's not just the input context size. And if you take any LLM, usually they will charge you $2 to $3 for 1 million tokens in, but they'll charge you $10 for 1 million tokens out. Out tokens are always way more expensive than in tokens. And there will be certain enterprise use cases where the out tokens are actually very large. So the cost changes significantly when you're dealing with these kind of use cases. So in this case, we took a Gamma 431 billion parameter model, runs on a cluster of 2 MI350Ps. And there are agents which are servicing all of this, created in about 6 weeks, all written in natural language, and delivering close to $1 billion in savings on contract and invoice leakage. So these kind of use cases are possible now at a fraction of a cost that you would pay a large language model. So in this case, with a generic LLM, it would have per contract, that would have been 20,000 tokens in, and 2,500 to 3,000 tokens per invoice. So we reduced that down to almost 85% less with using a small language model. Now, I mentioned that once you take a small language model, your footprint of tokens by itself is less. That's a fact. But is that enough? What that means is now you're transacting with the model with fewer tokens. Input, lower, because you don't have to do few shot. Your small language model is already fine-tuned. It has a lot of the context. So you can now talk to it with very small size token windows and context windows. But is that enough? Not really, because the point is there are additional optimizations, as I said, that you can do on top. One of them is refrag. Think about what zip or 7-zip did to files 20 years back. The same thing now you can do to context windows. But to do that, your generational model, your embedded model, your re-ranker models, if you're using rack systems, all of them have to be able to talk in the language of compressed tokens. So there are techniques now called refrags that have been developed that allow these models to get trained to understand compressed text in the form of tokens that are compressed. And hence, you can further reduce 40%, 50% on top of already a small footprint with a small language model. Speculative decoding is something like this. If you take a language model, even if you take a 31 billion that I used for Gamma, or you take a Mistral 24, you take a Gamma 27, the models have certain layers that do very high-value tasks, like predictions and decisioning and reasoning. And certain parts of the model are doing the low-value tasks, tokenization, decoding, encoding. The question is, can you make the model work in a way that the model is doing the high-value task, whereas other little things can handle the low-value tasks? That creates the concept of speculative decoding. Speculative decoding was, if I'm going to use a 31 billion parameter model for doing my decisioning, reasoning, and predictions, I can use a 1 billion parameter model only, and that will do my tokenization. Because now the low-value task is being handled by a much smaller model, and my larger model is just supervising and saying, yeah, everything is kosher, that will give me even more throughput from that 31 billion parameter model. Now, in the newer techniques, the technique has become self-speculative decoding, where the same model you can target and you don't have to run two models. So there's additional techniques like self-speculative decoding, and Suresh talked about model routing. Always look at what's coming in and decide which model will best work for it. Don't assume that everything has to go to OpenAI or Gemini or Anthropic, because it doesn't have to. These concepts, custom KV cache fills, these concepts are built for one reason. That earlier used to be that you would do a static benchmark. Somebody from your AI team would go in, run a benchmark, and say, for this kind of a load, it's best to use this optimization technique. The problem with that is, it's basically saying one size fits all. But instead of that, what you need to do is do it dynamically. When you are ready to hit a model, you have to make sure that you know that if you hit refrag, compressed, you'll still get the right accuracy. If you do speculative decoding, you'll still get the right results. You'll get the same level of accuracy and performance. So you have to make a system which is dynamically deciding all these things based on the context and the request that the model has to handle. So those are the optimization techniques that were built with Uniphore, Rackspace, and AMD on MI350P to make sure that besides the fact that we've already dropped the model size, besides the fact that we don't have to carry a few short examples, besides the fact that my context window is already small, I can still use compressions. I can still say this larger model is not needed for these low-value tasks, that I can model route to an even smaller model. I can go to a 1 billion parameter model or a 500 million parameter model to do lower-value tasks, repeatable tasks, but do it dynamically at the time of inferencing. So the dynamic optimization, like the refrag, so self-speculative decoding, the KV caches, these were built with Rack AI because you need support from the Kubernetes layer to be able to handle some of these. The signals, the metrics are being read from the Kubernetes layer. Tuned for MI350 because a small language model, if you take a 31B parameter model, if you put it on 4 GPUs, you're still going to leave some headroom. So you need to optimize the model in a way that it reduces your footprint on the GPU itself. Use the memory in the most proficient and optimized manner. Now, MI350P, you can actually load up to a 70 billion parameter model, and believe it or not, on a single GPU, because you can activate fewer parameters and run it in the memory that chip provides. So now you can run a partition of 2 more instances of the model, get DR for free because you just are running it on a 1 or 2 GPU cluster. So the cost goes significantly down. If you consider this with a 1 trillion model or a 3 trillion model that Gamma is running, you don't even want to know how many GPUs they need to run if you want to run it yourself. Fine-tuning is a loop. So we discuss small language models, but small language models by themselves are not as smart as a large language model. You have to add your enterprise context into it. And that's where the fine-tuning steps in. Essentially, create a machinery that is generating fine-tuning instructions from your data, generating fine-tuning instructions from your agentic runs, learning from agent traces, learning from your context, feeding it back into the small language model, and the technique is called low-rank adapters. So generate low-rank adapters, generate quantized low-rank adapters. When you fine-tune, not train, that's why we don't use the word train. Fine-tune your model as low-rank adapters. Even when you're running the fine-tuning job, you don't need a scale-up on GPUs. You don't need 1,000 GPUs because you're running a training job, because you're not. You're running a fine-tuning job. And fine-tuning, if you're running a 2 GPU cluster, you can still run fine-tuning within that 2 GPU cluster. And finally, the sovereign deployment we talked about, some of this running on-prem, running on your private VPC, so all of that is possible. So what does it mean in terms of net benefit? Accuracy, almost 98 to 99% compared to frontier LLMs. Time to first token, on an average 1.4 to 1.5x better. Total throughput on a MI350P observed in that use case with 2.5 million invoices, 65,000 contracts, almost 4x higher. And hence, 85% lower TCO. And boy, in terms of power reduction, it's not even in the vicinities, neighborhood of how much you can save on power consumption, which is becoming the #1 issue in running these GPUs. So with that, back over to you, Suresh.
Thank you, Saurabh. All right, I'll bring you guys home with this, right? So this is the power of partnership. AMD brings in the best compute engines. Those compute engines reach out to customers like yourselves through our partners like Rackspace, deploying various cloud regions, fully managed private cloud for your sovereign workloads. And obviously, what brings this all together is a very intelligent enterprise AI business suite software stack that Uniphore brings to bear with us. So again, this is all going to come together in Q4 of 2026. You would start seeing these deployments in the regions that Amin just showed. We're expecting somewhere early 2026 that you're going to get access to this. We're already way in the journey to optimize all of this with Uniphore, but once it gets deployed in Rackspace, that's when you can get your hands on this thing. If you have any questions there is an email address over there, and they can help you with any of the questions. Again, very excited about this solution, guys. Sovereign, tokenomics, control. This is a solution that solves it all. Thank you.